Yo, folks. Thank you for coming here. Sorry for the little mishap. The MacBooks are not in a great shape today. We're going to do a workshop about Dojo. Dojo is a provable game engine using the Starknet stack. We'll do a short presentation about what Dojo is about, and then we'll get on to the nitty-gritty, and Lo will present you exactly how it works through a real code example with a game that we built using Dojo. So I'm Sylve, the one with gray hair. I'm the co-founder of Brick and a co-contributor to Dojo. Loaf over here is the co-contributor for Loot Realms and a man of many talents, obviously. So what is Dojo? Dojo, picture that it's a little bit like Unity. It's a game engine so that you can build and run provable games. What do we mean by provable games? Provability is a fundamental primitive that is allowed by zero-knowledge proofs. It means that you run the computation once, and then it's very cheap and very easy to verify for someone else. We get a lot of really, really cool affordances, and if you've heard about on-chain games, there's a bunch of people who are trying to run the games on the blockchain because it gives you higher composability, higher resistance, higher resilience. And what we're thinking is, okay, it's really cool to put things on-chain, but how about we make them provable first and maybe put them on-chain when it makes sense. So we get all kinds of crazy things, such as client-side proving. I play on my laptop and then generate a proof and verify this on-chain so that it doesn't cost me $3,000 to pay a round of chess. I just need to send a single proof on-chain, and that's what really matters here. Some of the cool stuff that you can actually do is, so you've got the security on Ethereum, that's layer 1. If you're already familiar with layer 2s, the really cool thing is you do a whole bunch of things here and you just send the proof back to L1. But why stop here? We can just go and recursively do the same thing over and over again. You can just play a game on another layer 3 and just send the proofs back to L2. Or you even play locally, send the proofs back to layer 3, yada, yada, yada. That's the really cool thing that provability allows you to do. So what is exactly Dojo? You get the core engine, that's actually Dojo. It's built using Cairo, and we've extended the Cairo compiler. And we've added a whole bunch of other tools that just make the developer experience a lot easier. So we've got Sozo that just helps you if you want to migrate or upgrade the construct that you already have on chain. You've got a whole suite of devnets that help you build locally, test it out, and then deploy either on your own. Layer 3 like Madara or directly on Starknet. And we're working on bindings to clients so that once you've built your game locally using Dojo, you can very easily spin up a client so that your players can actually use it, whether it's TypeScript, React, Bevy, and we're also working on Unity and Unreal. So I'll just skip this thing and just go a bit faster. There we go. So this is what we're going to do. We're going to build StarkLander. It's one of the very first games. So we're talking about like 71. We had just landed on the moon, and people were like, oh, it's really, really cool. I would like to land on the moon, but on my computer. So a bunch of people created a genre of games called lunar landers. And the gist of it is, if you can see over here, you see how high you are, how fast you're going, how much fuel you've left. And the objective of the game is you're a little astronaut in a spaceship, and you try to land on the moon without crashing. So what you can control here, for instance, is how much fuel you're burning in order to slow your descent, but not too much that you don't run out of fuel and get lost in space. So we're going to rebuild this exact game using Dojo. So some of the cool stuff that you can do, because we're a provable engine, it's, let's say I play Lunar Lander, I make a really good score locally, I play like 10 games, and I got a really, really great score. So what I want to do is prove to the rest of the world that I'm the best StarkLander player. So what I can do then is I can generate a proof locally and verify it on chain. And I've played a whole bunch of things, and if I were running this fully on chain, it would have cost me an hour and a half. But because I'm only sending on chain the proof of what I've done, it is still trustless. You can verify the client's input, but it comes at a fraction of the cost. There you go. So this is what the interface is going to look like. We've got a little character over there that is just saying random stuff. And then your descent starts in 3, 2, 1, and then the counter will start ticking. You see second 1, second 2, second 3. You see how high you are, how fast you're going, and then you can input either how much you want to burn and exactly which angle you're going to input so that you don't crash in. It's very low tech, but it's it's pretty difficult to actually land without crashing. I haven't managed to do it so far. So that's it. Yeah, we still have some stuff to build. So the basic gameplay loop is the following. You click start, the game starts, either you win, yay, and you can submit a proof to the leaderboard, or you fail miserably, and you just start over until you get something that actually works. This is the basic architecture for the game between the entities, the components, and the systems. We'll get to that a little bit later. And yeah, that's about it. So I hope you all brought your laptops. What you need are some basic knowledge of Rust, patience, and giant steps, because obviously giant steps are what you take walking on the moon. So first off, I'll let you do the rest.
So we're just going to jump straight into it? We're going to jump straight into it? Okay. I'll share. Oh, all right. We good?
Yep.
All right. I'll just sit down here, maybe. All right, so Sylve really went deep into like what we want to achieve with this game, and I guess it's a lesson in trying to do so much in a week. So this really is a game that we made in a week with a discussion. Sylve and I were like, yeah, we'll make it StarkLander. How hard can it be? It's not that hard, but you know, there's a lot of little pieces, and you know, it's coming together, and maybe there's some Chads in the audience that can actually fix some of the live issues while we're doing this. But I think you know, the goal of the next 30 minutes is get Dojo installed on everyone that has a laptop here, show you how like components work, show you how systems work, and just show you the overall architecture. And you know, maybe we'll fix a couple bugs, and I'll run through some code, and then we'll go from there. And it's all, you know, and just a little, you know, little backstory about Dojo. Dojo is kind of the amalgamation of all our learnings for the last 2 years trying to build games, and so it's really the goal is to allow you to go from 0 to 1 building these games in a couple days rather than, you know, a couple weeks. Because a lot of people don't want, you don't want to have to rebuild some of this infrastructure. You don't want to have to think about the architecture. It just abstracts that away and standardizes it into a set of, you know, systems and way to do things, just to make it a lot easier for you. All right, so. All right, okay. So yeah, we're going to do this pretty live. I would have liked to be a bit more prepared, but you know, I just flew in from Australia a couple of days ago, so I'm still fighting some jet lag. But yeah, we'll do it. And if that little screen wasn't enough, this is like this is a GUI version, so you can kind of have a bit more visualization of what's going on. Maybe someone can actually build this as the next iteration of the game. And one interesting thing about on-chain games is that because they're all running, well, you know, all the code's open, all the interfaces open. You know, anyone can build the clients for these games, and so, you know, yeah. But that gives you an idea of what we're trying to do, and we'll do all the physics, and we'll has anyone written Cairo here? Cairo 1 here? One person? Rust? Couple? All right. All right. Well, here we go. So this is everyone with a laptop following along? Got to here? First thing you need to do is clone, obviously. And now, once you've done that, we just need to install Dojo. So flip to your code editor. And just do the curl. And then from there, you just need to do Dojo up. Are you going to hold that for me? Oh my God, okay. So what this is doing right now is this is installing the Dojo like toolchain, which includes a local devnet. So if anyone's familiar. I don't think you're showing VS Code. Ah. You should show it. Okay, hang on. We good? All right. Yeah, we're good. Yeah, so that if anyone's familiar with Foundry, this process is definitely inspired by Foundry, with Foundry Up, which just installs a bunch of binaries. So Dojo Up installs 3 binaries, which is Katana, which is the local DevNet, Sozo, which is like a utility manager for managing your worlds and migrating them to the DevNets, and Tori is an indexer, which you can just run and it'll index the state of your world. It's all standardized, and then it exposes a bunch of endpoints which then you can query into your clients. And so these 3 tools basically allow you to get up and running in an instant. So once you've done that, so I'll just go through so we've got a couple folders here. We've got the client and we've got the contracts. Probably spend most of the time in the contracts, but actually maybe we'll just go straight to the, I'll just get up and running. So hang on. So go into the contracts directory, and there's in the README, here's a Katana command. So just run that, and that's created a local DevNet with a 1-second block time, with a bunch of accounts you can just use in any environment. So once we've got Katana up and running, we just need to migrate the code. I'll explain this, but we'll just get up and running into the client, and then so you just go sozo build firstly, which just compiles all the code. And as Sylve mentioned, how Dojo works in the back end is we've extended the Cairo compiler to
Control plus.
I don't know, maybe Command plus. There we go. There we go. Is that good? What was I saying? Oh yeah. So the interesting thing about Cairo is that we've extended the Cairo compiler into, and so when you write code in Dojo components and systems, there's a bunch of shorthands that just expand out into like the syscalls, and so it's much easier just to write code. And then when Sozo build, it runs the compilation and expands those macros out into the actual code you need. So you need to do that before you when you make changes. And then you go Sozo migrate. And what this is doing, this is just deploying your world to the local Katana instance. And outputs a world address. And all interaction with Dojo is all done through the world address. And the way so you execute everything through the world address, and it pipes it to the specific systems. And all the state is contained within the single contract. So yeah, so that's up and running, and then we'll just get the client going. Client's just a little Vite app, so I'm sure everyone's messed around with that once, twice. So start. So this is where we're at. There's definitely still some stuff to do, and there's some bugs. Anyone that's built a game probably feel me. It was overly ambitious, but the good thing is it's all up on GitHub and there's some issues open, so if anyone is really powering ahead, try and tackle them. But yeah, what this is doing here, this is reading the local state and just printing out the computed values of the of the velocity and the altitude and your fuel. When I hit fuel, we're burning some fuel here. So the goal is basically to land at like 0 velocity, at like the right angle, when you're at like 0 height with enough fuel left. So that's the end game, but we're getting there. So yes. So this is where we're going to, but we'll go through the. Sorry. We'll go through the We'll go through the contracts first. So anyone's familiar with Rust? Cairo is very similar to Rust. I mean, it's heavily inspired, and so all the same modular mod structures. You structure a component very similarly. And so you have your lib, which exposes it, and then you import your nested modules like this. exactly like Rust. The interesting thing about Cairo and Starknet is that like it is a way bigger, like you can just create monster contracts. You can have giant code bases, and it's very easy to maintain large Cairo code bases over like Solidity. I mean, Solidity is great, but like it's kind of breaks down when you make gigantic projects. It becomes, yeah, very hard to manage. So we're not going to do like a full deep dive on everything Cairo, but there's some great resources. There's the Cairo book, which I suggest anyone that's really interested just read that back to front. It'll explain all the intricacies of it. But we'll just go through a few things here. So we've got in the systems, we've got our 3 systems here.
Can you just quickly explain what we mean by entity systems and components?
Yeah, so Dojo is structured around the idea of an ECS system, which is an entity component system. And the idea with an entity component system was like designed in like, I don't know, 2006 by guys that were creating MMOs. And it allows you to like abstract the state of entities. So like, let's say you have a human and a monster, you know, both humans and monsters share health, right? So instead of like creating a monster health and a human health, you just create one health component and you connect them through like a, you know, like a foreign key, which is the entity ID. And then you just extend that entity, you just add more components to it and you share the components around, and it allows you to extend the game significantly. You know, it's a lot easier to like create very complex games and add more entities, add more complexity to your game. So that's everything we do in Dojo is structured around that. What we've done actually here is I've actually created a bunch of tasks. And so just because I was trying to get this up and working as fast as possible, I actually haven't abstracted the lander into the components because it's just single player right now. But there's an open issue to abstract like for example, we could abstract the position and the velocity and the fuel into their own components. And then those can be shared through like, you know, maybe we can introduce asteroids or like other spaceships in the world with the shared components. So that's why we're just like, you know, we're just roaring it straight into the lander right now just to get anybody that's built anything, just get the first version working and then you iterate from there. So that's where we are right now. And there's a fuel component. That's probably the easiest one that can be abstracted. So one of the other interesting things about Cairo is this. It's got a very nice extensibility to it, and you can create really. You can just create these little libraries. So what I've done here is. It's a little convoluted how I've done this, but I did it as an example. You could probably put this in the main code, but anyway, you get the gist. What I've done here is I've created another little directory, which is like its own library. So this could be in its own specific repo, and you can install it. So we could install it in the main repo, just like this, as a dependency. So we could, you know, if this was like Lander, oh, it is there, sorry. Lander math, right? So I'm just importing Lander math as a dependency into like the main project structure, and you can import, you know, Git repos like this. So we've got Qubit, which is our fixed point math library, and yeah, of course Dojo as the other dependency of this project. So in the Lander library, we've created a struct and an implementation of that struct to do all the physics calculations. It just makes it, you know, a lot easier. And so if anyone's familiar with traits in Rust, it works basically the same way. You define your traits, and then you make the implementation of those traits. And what this does is it allows you to, you know, when you're writing tests, you know, so Lander here is the implementation of the Lander. And I can just do lander.burn because it's a part of the implementation, and then I can pass the the variables in, and then, you know, we've moved the state just by doing that. So it's like these little things really add up when you're making these big projects. And Cairo is like unique because it, you know, it does compile to these circuits, and you can run it on, you know, you can prove this whole program. These little things really do add up when you start making big projects. So yeah, so here we've got like we're doing the burn calculation, which it's using fixed point math, which because, you know, as everybody knows, you can't do floating point on blockchains right now. Really, you can't do it on Ethereum. You can't do it on Starknet either. So we use fixed point, which basically just creates giant numbers, which then you divide, so you can get more accuracy in decimals. So we're doing the, if anyone actually is a physics expert, just speak up. But we did actually get a physics guy to help with some of this stuff. So, but it's pretty simple. And we're just, we're adjusting the force, updating the velocity, updating the position, updating the fuel consumption, and then we're saving it. And same with the position. The position just pushes the, the lander forward according to, where it is in time. So that's the library. And then we import that into the main Dojo project. So we've got 3 systems here. We've got the start system. And so all Dojo systems, the standardization is like around, every system just has a single execute function in it, which standardizes all the interfaces downstream as well, makes it a lot easier. And so execute in this system just takes the player ID, which is their caller, creates a game ID with a shorthand, creates a storage key, and then sets a bunch of values in the world. So when I was talking about the macros before, so this is what the macro is. So instead of writing like, I'm going to call the world contract and store the state and all this like longhand stuff, you just write set exclamation mark and Dojo expands that in the compiler. And so that's just setting the state of the world according to the storage key here. And that's all the start system does. So then after the start system, we've got a burn system. And the burn does, it'll adjust the trajectory according to the thrust, the angle, and the delta. And this imports to the library. So, we're just going through here, we're creating the player ID, creating the storage key. Then we're creating a lander, and this is another shorthand, just get. And so this is just getting the state according to the query, which is this. So it's quite nice just like being able to do this. So you can imagine like 20 systems, it really stacks up. Then we insert if there is fuel, get the difference between the time. Then we extrapolate the position according to the state, because obviously we can't keep computing we can't keep updating the actual state. So what we do here is we store the last update time, and then we push through the time difference since the last update to get where the actual lander is. And then with that updated position, then we do the burn, right? Which then adjusts the trajectory. So we're just converting to fixed point here. And then we get the trajectory back, and then we store that updated state in the last update. And so that's what the burn does. And the position system is really just a view system right now. It's just calling the database and just returning the position so we can see where the lander is in real time. And we just replay that out into the table. I can probably just stop here. Does anyone have any questions? Going too fast? Too slow? We're good? Problems installing? Everyone got Dojo up? Anyone got Dojo up? You got it up? Nice.
Can you walk us through like the wind conditions and how do you check that you've crashed or not?
Yeah. So that's actually one of the systems there's an open issue for. But I built the library for it, so it just needs to be implemented. So if you go into the components, so we've really only got this one lander component right now. And with the components, what I was describing before with the library, you can extend it with the traits. So we've got a trait here, which is position, burn, has landed, and the conversion to fixed point. And what this does is just, I'll show you. So this implementation here, the burn, so when we get the state, it's then, it's defined as the lander struct component. and we've created this bunch of traits, so we can easily just adjust the state and, mess with the struct with position. So lander.position is just calling position, which is passing in the self, and the elapsed time, and then we compute the position according to the library, and then we just return the value. And same with the burn. It's all done in the library. We've just kind of made like 2 layers to it. I made the Dojo component implementation and the library implementation for reference. But you could probably put it all in here. But yeah. Yeah. So there's the position, and then the has landed condition is really just, is the lander, in a negative y position, and does it have a velocity of like 0.1 meters a second, and is it angled up? And that's basically the win conditions. And if it is, then then you can win. But the system that to be created is hitting that, because the game, the chain can't interact on its own. You need to actually make the interaction to change the state. So what I'm thinking is we just in the client, you can see where you are according to the readouts, and you can just hit like a land button, and it just checks like actually if you're in the right vicinity, and that's really the win condition. Another interesting thing about Cairo is, I'm hoping I'm shilling Cairo a bit here because it is really interesting. You should really just take a weekend and try and fool around with it.
I think it's a lot of. Okay, so let me use this. Like, it's obviously a lot of ones, right? Like, what I was thinking is like, how, if you were to build this game right from scratch, like, where would you start? I know you kind of went in it already a little bit, but I'm just thinking from the perspective outward to build, like on mud, right? I would like start with the entities, and then like, if you can kind of go.
Yeah, sure. No, good question. I was probably going a bit too fast. Yeah, so the way that I kind of approached this was, well, let's create a generalized library first of the physics, which is basically the whole game, right? And so that's what I made this first, and got all the calculations and everything working in this kind of like stateless environment, because it's not a contract yet at this point, it's just a library. And libraries are a lot easier to test. So kind of like my kind of work stream is build a library, then write the unit tests of the library, to get all that working. And then once you have all the libraries, which is basically all the logic of your game and the logic of your contract, and you can do this in lots of other, do it in every other development as well. And so then you can be certain that your unit tests are correct. And so that was kind of the approach. I was like, let's create the physics first, and then as these, this little API endpoints, the position and the burn, which is really just they're the 2 functions. It's just like checking the position and adjusting, and the win condition. It's pretty simple, like for this first iteration. So after the library's working, and then we're like, okay, well then let's turn it into the Dojo kind of abstraction. Yeah, and as I was saying before about we could have gone straight into abstracting all the components, maybe, but I don't know. I'm on the approach of just get the thing working first, and then iterate on it, rather than like over optimizing to begin with, because you end up just like in a mess. So that was the approach that I took: is just get the single component working. And then abstract the state into a more modular way. And then once it is abstracted, let's just say, I think I've gone pretty deep, so I'll just talk about my kind of where I think we can go next with this. So yeah, so once this is like working as expected, and the client's another story, we'll get into that. But let's say this is all abstracted into its components, and then we're like, okay, well, we have our start game. Start game's pretty simple. It just spawns the lander at a random position. Still need to do the randomness, but it's just spawned at like 12,000 altitude right now, and 1,000 x, and 1 velocity and 1 y. That could be randomized just to add like a variance to the game. So every time you start, you're in like a different position. So it's you have to like do the maths on the fly. It's a pretty hard game. Yeah, and so, perhaps after this is done, we can create maybe a distorted land, so it's harder to land on, although that might even be too hard. Well, I don't know, maybe we say like, maybe there's an asteroid that you need to dodge or something. That's simpler. So, to create an asteroid, right, so since we would have the lander positions, since we would have a position component, we would just create since we have a position component, we'll just create another system. So maybe we'll just go. Let's just, because I'm lazy. Yeah. No, I don't want that curve violet. So let's just say we've created like a rock now system. And so this would just, all we need to do here is we need to just spawn the rock at a specific position, right? So spawn rock and set the position. And we can set the position, like, this is probably not going to work because this thing isn't set up, but we'll just go just to show you, right? Yeah, so let's assume that this component exists, position. Let's just make it. So we made a position component. That's all you need to do. That's all you need to do. I think that's one of the interesting things about Dojo is that it just gives you this pattern in order to build these abstractions really easily. You don't have to think about, like when I was, I kind of started out in like end of 21 trying to build these games, and in Solidity, and there was no defined patterns, and over the year, we kind of defined our own pattern, but then realized it's still not abstracted enough. Like and this is like the real benefit of just like open source software and just the composability of software in general. You have this like set of standards. And so, if you understand the Dojo system, you can just go and look at all the Dojo games and just get them straight away, and you can build on top of them straight away. But everyone was like rolling their own like implementations. Everyone has their own infrastructure. Everyone has their own way of like writing the contracts themselves, and just standardizing everything. It just it streamlines it all. It's like recreating Unity every time you're trying to make a game. It's just insane. So this just gets you there. So we've got a position component with an XY. And we can just import it like this. That's all we need to do, just import it like that. And now we have it here. And we just set the values like that. Don't need to return anything. Yeah, so what I've done here is I've just set the, I need to get a query key. So Dojo has like an inbuilt database. That's one thing I didn't really discuss. And so when we're storing state here, we're storing it according to this key, and then we can fetch it from the key, right? So the key defines the entity. So entities you don't create an entity like a Cairo file. Entities are just IDs. That's all they are. And so you can define the entity ID however way you want, right? So what we're doing here is we're just hashing the game ID and the player ID to make a compound key, and that's what's getting saved. And then we use that compound key, and we set the position component, 1-1. And once we've done that, that will then, or we have to fetch that same key with get, as an example. Boom. So in another component, we'll just be able to get it like this. Yeah, so from this, we've set it here, just like that, and then we've got it again, and then we can do what we want with it. And so that's how simple it is just to set state and get state, which is like 90% of the stuff you do, right? And it just removes a lot of the boilerplate. And so let's say, so we've got a rock up and running. This will compile. We can just compile it. It should, maybe. Oh, sorry, hang on. Just going to build it. Yeah, so we're compiled now. So that component exists and can be called with these two parameters somewhere. I'll get to the client in a second. Yeah, so that's how easy it is just to create a new system and a component. Just as like 90% of the work, just creating these little components, abstracting out your logic. Well, you didn't make a fun game, but when you're writing the code, that's all you need to do. And then you just migrate it like that. So build, and let's just take down Katana. Katana's like stateless, so every time you need to like migrate it. I think we're working on a way to like have a hosted version that you can deploy to and can have consistent state as well. But right now, just in the development environment, you just need to reset it every time you're. So we're just going to deploy the new component. Yeah, see? And we're live. That's what it takes. So we've got a rock and setting the rock at a position. Yeah, probably just leave that there. Yeah, but then to interact with the client, it's just pretty basic JavaScript, let's be real. We're just creating a network. With a bunch of calls, execute function and a call function, and then we have a bunch of systems here, which we then call specific places. So, calling execute, we're calling the game ID, which is hitting Katana, and then it's returning the result. Anything other specifically you think I should go over?
Anything in particular you folks want us to deep dive into? Don't be shy.
Yeah. If there's any questions, we're just going off the cuff. The game's like, at this point, we need to fix the bugs, which most of them actually client-side bugs, which didn't manage to get to them. Improve the test structure, then abstract the components out, and then that's pretty. Then the lander will work.
I don't know. Could you try to spawn the rock on the client like right now? How? Yeah.
Yeah.
If it's too much work, no worries. But I was just curious to because it helped me to understand when you went through the process of like making
Building
the
the
execute
thing.
function for the rock,
Yeah.
and that was really helpful.
Yeah, sure.
But if not, no worries. Just
Yeah, no, we can. I'll just use some of this stuff. It probably won't be exactly what we want, but and like this is just the JavaScript client, right? But like
That's fine. I mean,
we're in the process of building. Has anyone played with Bevy? A little bit? Oh, good. Yeah. Yeah. Yeah, exactly, yeah. A lot of the syntax is actually inspired by Bevy in Dojo. But we're building a pretty sophisticated Bevy kind of integration SDK. Because I think Bevy is a really interesting engine, and I think it has a lot of promise. It's still pretty early and hard to use, but it's only version 0.11. So, but yeah, building games in JavaScript is okay, but you hit a limit and it becomes spaghetti after a while, and just the performance-wise kind of sucks. So any serious game, these little demos like this, great to just prototype in. But I think we need to move away from building games in JavaScript, I feel. And now we have WebAssembly and we can, there's alternatives. I think it's preferable. And you don't have to use Unity. That's why Bevy's great, because you can just compile it to WebAssembly and just run it in the browser. You can run it in all your devices as well. So, what are we doing? Oh yeah, we're gonna execute. Right, okay, so here's actually on ignite, right, function. So what we're doing here is we're just taking the angle, and we're calling burn. So all when you need to interact with a system in Dojo, you can just use the name of the system. You don't have to put the address in. You just put burn, which is the actual name of the system, and Dojo just knows that you want to interact with that. And then we're passing the parameters in, which, if we remember, game ID, thrust, angle degrees, felt, sine, and delta. And so that's these guys. And so when you execute that, that's interacting with the system, and you can see it. So this is the katana. So you can see there, I've created a transaction. It's interacting with it. So let's say we want to create that position. What was it called? A rock. What's it taking? So we're just going to pass in the game ID and the katana address, just the parameters. And that should work. So let's just hook it up to a button.
And so the rock button is just going to spawn a rock at a certain position, is it?
Yeah, it's just going to spawn it at 1-1 in the world. What did I call it? Create rock. Create rock. All right. And
Could have called it Let's Rock.
let's rock. Sorry, I missed a chance there. Something's bugging out. Hang on. Just going to reload. We're almost at time, aren't we? 50. Just going to remigrate. And I'll just wait until that's done. Ooh, what's going on here? Did I change something? What did I break? I just broke something. What did I just change? This is why coding live sucks. Just getting grilled. Yeah, I don't know what's going on with that. I'm just trying to see. I think Lander not found. trying to think what I did. I just created a component. Yeah, well, but you get the gist. That's basically clicking the button, and we would have seen it in Katana. Yeah, I've done something. I may have just written some random code somewhere accidentally. But yeah, that's as simple as is, right? So I think the key to get out of that is just the way you interact with Dojo is with the execute. It's similar to Mud in that regard. So you just pass in the system name and the parameters, and then you execute from the world address, and that's it. Yeah. And that will update the state, and then you can fetch it however way you want, manipulate it. So yeah.
Cool, thanks.
Yeah.
We're nearly at time. If there's any questions, we can just quickly go through them. I'll just give a quick shout out to the rest of the team who's worked on this. So I was the vibes operator. Hi folks. Loaf bore the brunt of most of the dev with Carrie over there. The great design is from ClickSave, Calvin from Cartridge, and what the dev is our physics professor who's on most of it, and the influence team is the other people who actually built the fixed point math library, because they're actually building an entire on-chain game about space simulations.
Using that library, which is insane. So they actually calculate the trajectory from, if anyone's played Kerbal, they're basically doing in Kerbal on-chain, and it's all simulated on Starknet using that library. So definitely go and check them out. The whole game's on-chain. It's probably the most advanced on-chain game that exists right now, but they kind of fly under the radar. But yeah, it's really interesting.
And if you want to learn more about Dojo, over here, get a link to the Discord, and this is the repo for StarkLander. So thanks a lot for coming.